This is a run through the 19 minerals that need to be known for not only the lab that you have on minerals where you list their properties in a sort of a table format, but also for the lab quiz where you have to be able to identify within about 10 to 15 seconds the mineral that's being shown to you or is in a video. So you'll need to use this to kind of review for your minerals lab quiz. So I have 19, 4 here on the bottom, and then 5 on up. That's 4 plus the 15, that's 19. And we're going to go through kind of each of them individually. So first one on the top left is vitreous, meaning glass-like. It has kind of a cubic, if you look at this top here, fracture or crystallization. I see it more in the crystallization of this mineral than I do when you hit it. And if it cleanly breaks into a three-dimensional sort of crystal, that's called cleavage, clean lines. But not as good in clean line cleavage as like Galena, which we'll see here in just a little bit. So this is cubic, meaning it tends to crystallize in a cubic manner when it forms the element. And this is NaCl, it's just sodium chloride. They call it halite. The next one is calcite. Now notice that it has what we call like a leaning house look. So instead of straight to the top and bottom, and it kind of leans a little bit. So you can kind of see it leaning. We call that a leaning house. Scientifically, that's called a rhombus crystal structure. Now calcite, you can't scratch with your finger. It's harder than a fingernail, but it's softer than metal. So I just want you to look at that surface. We'll show how you can take and you can make a mark on that surface. This is softer than the metal. So I can do that not with quartz. We can do this with calcite. You can also do it with that NaCl or halite that we just had, but that's a rhombus look that can often be confused. I'm going to jump right below it with a gypsum selenite. Gypsum selenite can also have a rhombus crystal structure, but it's softer than a fingernail. It says gypsum selenite, and it's softer than a fingernail. You can see that I've made that etch mark. It's softer. Both of them have rhombus looks to them. This is gypsum selenite, and there's also gypsum satin spar, and you might have either one of these, but you just need to know it is gypsum. It just tends to be, all gypsum can be broken very easily. It's softer than your finger. This is gypsum, that's calcite, and we had our halite. Now I do want to just kind of bring up one that's not at all vitreous. These have been vitreous, the calcite and the halite, and along with the gypsum selenite. Gypsum satin spar is just earthy, it's white. This one's metallic, it has a glitter to it, you can kind of see that. Glitters, and it also has, if you look at some of the surfaces, you can see a cubic kind of arrangement. Galena tends to have the same arrangement, kind of morphology as your halite, meaning cubic kind of arrangement. It's very heavy, it's very metallic, that's Galena. So we've covered 3 up here, we've gone 1 down here, just because it's kind of like your halite in terms of its cubic crystal structure. Kaolinite, back to things that are softer than your fingernail, you can take that and it's able to be removed with just your fingernail. This is kaolinite. Often has like an iron oxide brown streaks within it. See a little bit of brown here. But itself, it's white. It's very white. It's very soft, softer than your fingernail. And again, brown, they call it like a diaper, like almost dirty diaper look sometimes. Now, mica muscovite could be called vitreous, but notice that it's very platelet-like. It tends to, when it flakes in sheets. This is a kind of a basal fracture, where, or basal cleavage, sorry, clean lines, where we can take and peel away sheets of this. Try to do that here. I'm having a little bit of success. There we go, a little bit of success on this bottom one. I can take a sheet of it, and that's called a basal cleavage because it's cleaving along this axis going into this surface. It doesn't have very clean lines on 2 dimensions, but It's a basal cleavage, meaning it cleaves to make sheets. Mica muscovite, or muscovite mica. And the one that's just like it, but sort of the darker version, is the biotite mica. Biotite mica, you can see here, I'm starting to cleave it along that one dimension, the one dimension going into this plane. It has very clean lines, so it's a cleavage type of breaking, not fracture. And it's also a mica. It's called biotite mica. Clean lines on one dimension, making sheets. Now this next one, called fluorite, doesn't typically have a particular crystal structure or morphology. They come in either purple or blue, light blue, can have a blue tint, or even green. And if you think you have quartz, you think you're holding quartz, which you can take your keys if you're out in the field, or this screwdriver here, I can usually take and scratch the surface if it's fluorite with metal. So I'm going to see if I can do that with here. And I can see I've etched that mark. Now, if I try to do that with my next one with quartz, I can't do that. So this is leaving an etch mark. It's softer than metal. This is fluorite. It tends to be bluish, vitreous, but has a tint of blue or green or purple. It's fluorite. Let's just kind of go with the other ones that's vitreous. This is quartz. Now, if I try to do that with quartz, I'm not leaving a mark at all. This is harder. It's got a hardness of about 6 to 7, and this one's about a 4. This is harder. This is quartz. Now, you have different versions. This would be amethyst quartz, kind of purple rose quartz, and just your quartz crystal. You can have different forms of quartz. They don't have to be necessarily one form, but they are typically harder than metal. And only one on this board that's harder than that is corundum, so why don't I just go ahead and talk about that one. It tends to have a hexagonal crystal structure, so you can kind of see it from here. You can see that I have 6 sides, 1, 2, 3, and it cracked. So this is kind of a pillar-like look to it. It can often be in pillar form, like your quartz crystals are here. But it's harder than quartz. I want you to hear this. I'm going to have to put it on the deck because I don't want to break the glass. But this is like a hardness of, I want to say 8, and it's just the only thing harder than it is diamond as far as an element. So listen for the sound. It's dragging across the glass, and these vertical strips here, if I put my fingernail, it can get caught because it's made a groove on the glass. It's etched the glass. That's corundum. Corundum is harder than glass. It's the only one on the board that's harder than glass. A couple of ones that are easy just by color. Sulfur, it's going to be yellow. This is pyrite, also called fool's gold. This is feldspar. The best thing I can say is it looks like a meatball kind of sinew, you can see the white here. It can be considered maybe like a meatball look. It's hard. It's kind of as hard as quartz. It's a silicate. It's going to have different forms of potassium, calcium. They can have different shades of color, but this is just in general called a feldspar. All right, moving on, we just have a couple more on the bottom here. This is hematite. The big thing with hematite, it's going to have a sort of residue it leaves on your ceramic plate that's brownish or red. It's not necessarily soft. It just comes off in gritty form. It usually leaves a residue that's brown or red on your white ceramic plate. That's hematite. I didn't talk about this one here, right next to Galena. This is magnetite, and of course the idea here is that it's not the best magnet I have, but it's going to stick to a magnet, hence the name magnetite. So that's pretty simple to remember. Olivine for the olive color. This is actually just as hard as your silicate, but it tends to just break easily. Its grains are very, very hard, but they can come off sometimes easily. Let's see if it'll do it on the ceramic plate. Of course, it's not going to Yeah, I'm not getting, but sometimes it'll be just more gritty. It's olivine. All right, we've covered all the ones in the top row. We just have a few on the bottom row along with corundum, these last three. This is graphite. Of course, the best test for graphite is smooth. And if I put it to anything like paper or even to my finger, I can see it's left a little residue on my finger. That's graphite. Of course, copper just looks like copper. It's metallic. These are more earthy, the ones that just don't have a sheen to them. If they're more glass-like, they're vitreous. If they're metallic, they shine like metals. And that's what copper would be. Even if they're earthy, they just don't, they're dull would be another way to say it. This is talc. It can be white or it can be sort of this bluish turquoise look, but it's really, really smooth. That's the distinguishing feature of talc, is it's very, very smooth. All right, I've given you just the physical properties of these. Of course, there are chemical properties. Some are silicates, some are aluminum oxides. Some are going to be like Galena is a lead arsenic. It's very heavy because of the lead. But these are the 19 that you need to know for your lab quiz, especially because you'll need to be able to identify them within 10 or 15 seconds if you're doing it through the video or a virtual form. You need to be quick about it. All right, hope that helps. Thank you. Bye-bye.